Triangle sum theorem. We can use what we've learned to establish some interesting facts about triangles. For example, the sum of the angles of a triangle is 180 degrees. Let's actually see why. We are given triangle ABC. If we remove the corners from our triangle that is shown below and put them together, what type of angle is made? Well, let's actually try it, and then we'll answer the following question: what is the angle's measure? If we actually take angle A out, we can also take angle B out, and then if we rotate it around and put it together, right, like this, and then we take our last angle, angle C, and bring it together, oh, this brings up, or they create a straight angle. And what is the angle's measure? 180 degrees. And we have also proven that the measures of the interior angles of a triangle add up to 180 degrees. And here's the solution slide to this example, and it does match the solutions that we found. We found that the three angles, angle A, angle B, and angle C, when added together or placed next to one another, form a straight angle which measures 180 degrees. This proves that the interior angles of a triangle also sum to 180 degrees. Now that we have proven that the sum of the angles of a triangle is 180 degrees, let's use this theorem to find the missing angles of a triangle. What is the value of u in the diagram below? Well, let's construct our equation by adding up our 27, our 105, and the variable u together and setting them equal to 180 degrees. We have two constants, 27 and 105, that we can add together, and when we do, we will get 132 plus u is equal to 180. And if we subtract 132 from both sides, we get that u is equal to 48. And since the degree symbol is already listed after the variable u in the diagram, we do not have to put the degree symbol with the variable u. And here's the solution to the example, and the solution shown here does match the solution that we found when we worked. Now that we have proven that the sum of the angles of a triangle is 180 degrees, let's use this theorem to find missing angles of a triangle. So what is the measure of angle 1 in the diagram below? Well, we know that all the angles in a triangle add up to 180 degrees. So we can create this equation, 27 plus 105 plus the measure of angle 1 is equal to 180 degrees. And then we can combine our like terms and get 132 plus the measure of angle 1 is equal to 180 degrees. And then if we subtract 132 from both sides, we get that the measure of angle 1 is equal to 48 degrees. And here we see the solution to this example, and it does indeed match the solution that we found when we worked the problem. What is the value of the variable x in the diagram below? Well, x represents this angle right here. It appears to be obtuse, but we'll see when we find its measure. We know that the angles in a triangle sum to 180 degrees, so we can write the equation 27 plus 27 plus x is equal to 180 degrees because all the angles add up to 180. If we combine these two values together, we get 54 plus x is equal to 180. And if we subtract 54 from both sides, we end up getting that x is equal to 126. And here's the work required to answer this question. And it does indeed match the solution that we found. The value of x is 126. We don't have to put degrees as a unit of measure here because the unit of measure is included in the original diagram. What is the value of y in the diagram below? Well, we know that all three angles in a triangle sum to 180 degrees, so we can write the equation 95 plus 55 plus y is equal to 180 degrees. And if we combine our constant terms together, we get 150 plus y is equal to 180 degrees. And then if we subtract 150 from both sides, we get that y is equal to 30. And again, we don't have to use the degree symbol afterwards because there's a degree symbol already in the diagram after the y. And here's a solution to the example problem, and it does indeed match the solution that we found. What is the value of the variable w in the diagram below? Well, w is one of the angles in this triangle, and we can find its value by adding these two values up and subtracting it from 180, because all the angles in a triangle add up to 180 degrees. So we can take 71 and 41 and we can add them together, and when we do that we will get 112. And then if we take 180 and subtract 112 from it, we end up getting 68 for the value of w. We don't need the degree symbol because the degree symbol is already in the diagram after the variable. And here's the solution to our example, and it does indeed match the solution that we found when we worked it out by hand.